All right, I want to keep this nice and short. If this math seems foreign to you, you might need to go back, but make sure you know how to do SOHCAHTOA, because I'm just going to assume you do. For this one, we're given the x and y components, and we have to find the total magnitude. Well, that vector is going to have a magnitude and direction. So this should be pretty quick and easy. If you're familiar with the Pythagorean theorem in SOHCAHTOA, all this means is I look at my graph and it goes to the right 7.2 newtons per coulomb and down 3.6 newtons per coulomb. That negative sign means it goes down. All I have to do is do Pythagorean theorem and find out that this side squared plus that side squared and the square root of that is 8.05 newtons per coulomb. And even though you don't know what a newton per coulomb is, it doesn't matter. It's a thing to measure electric fields. That's what's nice about vectors. Later on, these will symbolize how powerful and the direction of magnetic fields, or forces, or velocities, or accelerations. We use this stuff all the time. The second one, there's your x component, there's your y component. What's that going to look like? Well, it says that x is negative 91, so I went to the left because it was negative. It said y was positive 67, so I went up 67. Boom, 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 some Pythagorean theorem. This is my answer. So I need to find two things, the magnitude and the direction. Because of Pythagorean theorem, this comes out to be 113 meters, but I'm not done yet. All I found was the magnitude, and vectors have two things, magnitude and direction. How do I find the direction? That's what SOHCAHTOA is for. You grab a calculator, make sure it's in degrees, and if it was me, I would look at this right triangle and think, well, that's my opposite, and that's my adjacent. So if I know opposite and adjacent, and I'm trying to find this angle, I would use tangent. Tangent of my mystery angle is opposite over adjacent. Put that in your calculator, and that comes out to be 26.6 degrees. If you use that negative, you'll actually get a different answer. It's going to start here and go all the way around. Well, when I was looking at it, I was looking at this little right triangle, not the big angle. It doesn't matter. You find them both as long as you know which one's which. For this one, I do the same thing. If I was searching for this angle, I would call that my opposite and that my adjacent. Put that into my calculator without the negative sign, and I'd get that inside angle is 36.6. If I use that negative, I would have found this angle was 143. So whether you're getting 143 or 36.6, it doesn't matter. They're both the right answer. You just got to know which one you actually found. I see it as that angle. If you use the negative, you might find that angle. Okay, that's how you take x and y components and find the magnitude and the direction. If that didn't make sense, make sure you watch it a couple times until it does, because we're going to use vectors all through the course. All right, thanks for paying attention.